So welcome to this introduction to the data center troubleshooting agents. In this write-up, I discuss why I picked this use case. We talk in a bit of detail about what a data center looks like, what the core protocols are, what the agent architecture looks like, plus what we can look forward to in the future. So just very quickly, data centers are critical infrastructure. And at the heart of this infrastructure is the network. Without the network, we would not have access to AI online. We would not have access to a lot of the critical services and systems that we rely on day to day. So when things go wrong with this network, when there are failures, we feel it, millions of people feel it. And so this solution is meant to proactively monitor these networks and resolve in seconds. We'll see that in the demo, issues that happen in the network. I encourage you to read this write-up and play with the notebook. If you have any questions, please reach out. I will switch to the Kaggle notebook now. So right here within the notebook, we have an illustration of our team of agents. The same picture is also in the write-up. The team of agents is put to play. They are triggered to action when a ping failure happens. So that's one of the strong points of this solution. We don't have agents lying around doing nothing. They come to life when there's a failure, and they get parked when the failure is resolved. This solution relies on proactive monitoring, which is a standard practice within networks and within data centers. Proactive monitoring allows network operators to detect issues within milliseconds of these issues happening. This can be silent failures as well. And that's where the ping is really useful. It's continuously checking for connectivity between hosts or different entities in the data center. And when a failure happens, in our implementation, the investigation coordinator is triggered. It comes to life, and it brings with it a team of sub-agents, which it invokes. And each investigator specializes in a layer of the protocol within the network. When these investigators have done their work, they provide a report. Each one provides a report to the investigation coordinator. And as part of the sequential flow, the investigation coordinator sends the details to the resolution coordinator, and the resolution coordinator analyzes these details and comes up with a plan to resolve these issues. The resolution coordinator, as you can see, has a couple of tools at its disposal. The tool at the bottom here is a tool to make configuration changes to the network to resolve the outage. It relies on human approval because, as we've come to know, these networks are critical. So a human must approve any changes that the agent makes in the network. For issues that the resolution coordinator cannot resolve or is not allowed to resolve, the resolution coordinator will immediately create a work order for the human to complete. So let's run through this Kaggle notebook. I've run a lot of these cells in advance to save time. Please do play with this notebook. Of key here is the simulations. Feel free to play with these Boolean values to simulate different failures in the network. You'll see here that we are simulating in this run a EVPN interface that is down because it has been administratively set down, and a BGP peering that is down because it's a failure. We know it's a failure because administratively it's up. So let's go right to the bottom of our notebook and let's trigger our simulation flow of a successful ping and then failure to the ping, which triggers these agents into action. So you can see here, one ping was successful, and then the second ping failed. And because these are proactive tests and we want quick resolution, the investigation coordinator is triggered into action immediately. Now, what we expect is because the EVPN is administratively down, a human would be required to bring it up, right? And you see right here a human decision. The human has approved bringing the EVPN admin up. As we saw, the BGP peering was down because of a failure. So we expect a work order. And we will see that right here. This is a summary of the agent or the team of agents' work. So we have the resolution coordinator saying that the EVPN interface was set to up. That's good because the human approved that operation. And a work order was created for the IBGP peering issue. Thank you for your time.